Welcome to qnawire.
Our question says a body is traveling at 2 meters per second along the positive direction of an x-axis. No net force acts on the body. An internal explosion separates the body into two parts, each of 4 kilograms. So I say M1 equals M2 is equal to 4 kilograms, and the total mass, which I call M then, is 8 kilograms. And it increases the total kinetic energy by an amount of 16 joules. So delta K is equal to 16 joules, and the initial velocity here, which I call V of 0, is 2 meters per second. The forward part continues to move in the original direction of motion, okay? What are the speeds of A, the rear part, and B, the forward part, if the forward part continues to move forward in the original direction of motion? So we're going to start out with conservation of energy. So conservation of momentum. So the initial momentum, mv0, is equal to m1v1 plus m2v2. Okay, so we want to find V1 and V2, where V1 is the forward part and V2 is the rear part. Okay, so from this, we realize that V2 is equal to 4 minus V1, where of course meters per second is implied for the 4 since it's SI units, and that's just from plugging in the values for M, the value for M1, the value for M2, and the value for V naught. That's what we end up with. But also, we know from conservation of energy that delta K is equal to the initial, the final, which is 1/2 M1 V1 squared plus 1/2 M2 V2 squared. So that's the final minus the initial, which would be minus 1/2 M V naught squared. Okay, well, this is 16 joules, right? Is equal to, we can pull the 1/2 out front, as well as M1 is equal to M2. So we can just pull one of those out front. So because they're the same value. So 1/2 M1. So this would be V1 squared plus V2 squared minus 1/2 M V naught squared. Once again, using the values for M, the values for M1, and the value for V naught, we find that V2 squared is equal to 16 minus V1 squared. So now we have 2 equations and 2 unknowns, right? Our 2 equations, I'm going to mark them by a red star, are this one here for V2 and this one here for V2. So for V2 and V1. So 2 equations, 2 unknowns. We'll plug in the first one into the second one. So we have 4 minus V1 squared, which is what we had for V2 in the first equation, squared is equal to 16 minus V1 squared. Solving for V1, V1 has to equal either 0 or 4, and then units here, of course, are meters per second. Okay, but for part A, we are asked to calculate the speed of the rear part, and since the forward part keeps moving in the original direction, that means the rear part must be the one that stops. So we'll call the rear part, which is V2, has to equal one of those, which is just going to be 0. It's the one that stops, meters per second. And then V1 has to equal the other one then, which would be 4 meters per second. So we can box both of those in as our solutions to part A here and part B here.